we will show how to conduct chi-square test in Python. We will first briefly introduce chi-square distribution. So chi-square distribution is a continuous distribution with degrees of freedom. So it is used to describe the distribution of a sum of squared random variables. That's why the name in the distribution has a square. So chi-square distribution's random variable is called second moment random variable. So it is also used to test the goodness of fit of a distribution of data. So this is in a linear regression, and whether data series are independent. So this is called independence test, and for estimating confidence surrounding variance and standard deviation for random variable from a normal distribution. And if we say 1, say 2, say n, an independent standard normal distribution random variable, then x, if x is the summation of say 1 square, say 2 square, and plus 2, say n square. So x will follow a chi-square distribution with n degrees of freedom. So the notation of chi-square distribution is chi-square n. So this figure shows several chi-square random variables density curve with different degrees of freedom. So for K1, this line. And for the K2, this side. So for the K2, actually, it is an exponential distribution. So in application in regression, S is which means sum of squared residues divided by sigma square has a chi-square distribution with n minus 2 degrees of freedom. And in independent test of two categorical variables, the test statistic follows a chi-square distribution with r minus 1 times c minus 1 degrees of freedom, where r and c are rows and columns number of contingency tables between two categorical variables. And the chi-square test statistic calculation has this form, which is the summation of observed value, observed count times the model expected count, take square divided by model expected counts in the table, then take summation for all the elements in the table. And actually, the chi-square distribution is an example, special example of gamma distribution. So we know this is the gamma distribution density function with the parameter alpha, beta positive real number. But if we let alpha equals nu divided by 2, this alpha beta calls nu, which is the degrees of freedom in chi-square distribution. And the beta equals 2, so a gamma random variable becomes a chi-square random variable. So with the following density function. So this is density function for chi-square distribution with degrees of freedom nu. So in this two density function, gamma alphas is an integral of 0 to positive infinity with x alpha minus 1 power times e minus x power conducted integration over x. So the mean of the chi-square distribution is its degrees of freedom, nu, and the variance equals 2 nu. So this is a table called chi-square distribution probability table. So if we look at this alpha is the probability is 1 minus the cumulative probability associated with this chi-square value in the density function. So from this table we can find from the value for the chi-square value in terms of different degrees of freedom and alpha level. So for example, in a chi-square test, we will find we'll find this number if it is larger than the critical value in the chi-square test, or we from these two values from the degrees of freedom and chi-square value find the alpha level. If alpha or p value less than the critical 0.05, so the test is significant. So chi-square test aims to first calculate the chi-square value and degrees of freedom from observed data, then get the alpha to determine if it is significant if it is less than 0.05. So chi-square test, also called Pearson's chi-square test, is a statistical hypothesis test for independence between categorical variables. So one of the widely used examples for chi-square test is to test the independence between two categorical variables. And the calculation of the test statistic is based on a contingency table, also called crosstab, which summarizes the relationship between categorical variables. So first we define a null hypothesis. In null hypothesis, we start by defining our null hypothesis, which states that there is no relation between the variables. So there's another hypothesis called alternate hypothesis. It would state that there is a significant relationship between the two variables. So after the calculated chi-square value in chi-square test, we will check if the value of chi-square, so chi-square value calculated if it is less than the critical value of chi-square, which also means if the p-value less than 0.05, so we will reject the null hypothesis and states there is a significant relationship between variables. On the other hand, if the p-value larger than 0.05, we will not reject the null hypothesis and state that there is no relation between the variables. So next we will show how to perform a chi-square test in Python. So we have to import function called chi2contingency from scipy.stats module. So if you have not installed the scipy module, you have to install scipy first. So my function is imported. So create a data array. So this array represents a 2 rows, 6 columns table. So next we can run this function of this data. So chi2contingency data. Then this is the output for the test statistic p-value, the degrees of freedom, and expected several output values. So we also set alpha 0.05. So this 0.05 is most widely used p-value in chi-square test. So next we print out the result. So if p less than alpha, the result is dependent. We'll reject h0. Null hypothesis will be rejected. And if p not less than alpha, the independent h0 holds true. So you can see in this example, p-value is much less than 0.05, minus 12 decimal point. So result is dependent. These two variables dependent because this table represents the contingency values between two variables. There are 2 rows, 6 columns, which means the first variable has two categorical values and the second variable has 6 categorical values, right? So the result is these two variables are dependent, which means reject h0 because p-value is much less than 0.05. Thanks for watching.